All right, this is Professor Pelton. This is part 4 of chapter 3, section 2. So now we're going to do piecewise functions. So all it is a function in pieces essentially. So this function has 3 pieces, and there's 2 parts to a there's 2 parts to a piecewise function essentially. What we have here are the functions themselves and their domains. Okay, so these parts are their domains, right? And these are the function part of the equation parts. Right, so the first one is y equals 3 over 2x, or 3 over x plus 2 for x is less than -2. Okay, so I'm going to do a dotted line at -2, just for visual sakes. So anything that's less than that is where this one goes, essentially. So you can do a table of values, x and y, right? And you can do -2, -3, -4, -5, -6, and just keep going forever because it's anything that's less than -2, correct? So if I plug this in, 3 over 2 times -2 plus 2, so that's going to be -3 plus 2 is -1. We'll do the next one here. So 3 times -3 over 2 plus 2. So that's so that's 9 over 2 is 4.5. So -4.5 plus 2 is -2.5, right? And then let's see, 3 times -4 over 2 plus 2. So that's 12 divided by 2 is 6. So -6 plus 2 is -4. I guess we'll do a couple more here. All right, so -5 over 2. Yeah, I think it's going to be off the graph anyways, right? So that's going to be 15, correct? 3 times 5 is 15. So -15 divided by 2, so 7.5, right? So -7.5 plus 2, -5.5, right? So if I did 3 times 6 is 18, divided by 9 is, let's see, 3 times 6 is 18, divided by 9 is not 2. Sorry, divided by 2 is 9. So that's what, -7? Okay, so -2, I meant -1. All right, and I'm going to put a open circle. Let's talk about that in a second. So at -3, I'm at -2.5. At -4, I'm at -4. 1, 2, 3, 4. At -5, I'm at 5.5. At -6, I'm at -7. Okay, so we basically have a line that goes like this, which makes sense. It is a linear function. Okay, and the question is, why do I have an open circle here? And let's unfill that circle there. Okay, and the reason it's an open circle is because the domain specifies that you do not have -2 into there. All right, so the next one is, we'll do this is an easy one. Y is equal to 3, right? So this one we put down here, and this one we're putting over here, right? But this table is easy. You do an X and Y table, and the values go from -2, -1, 0, and 1, right? And every time the value is just 3. It's easy. So at -2, I'm at 3. 1, 2, 3. Then I'm at 3. Then I'm at 3. Then I'm at 3. And this is a straight line. It's a constant function, although I kind of missed there. And the thing is, I screwed this up because this is not a filled-in circle. This is an open circle. Again, you can put the dotted line there to see the domain break. These dotted lines don't actually exist, though. I'm just doing it for visual purposes. You can see that this function only exists between the two dotted because it's between -2 and 1, but not including 1, which is why I put an open circle. Okay, so the last one is y equals x squared minus 5 is the last one, right? The last piece of the piecewise function, correct? So this one's going down to here. So this table of values, I can only put in the ones that are greater than 1, or 1, 2, 3, dot, 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 right? Because I'm using this domain here. Okay, so if I plug in 1, I'll get 1 minus 5 is negative 4. If I plug in 2, I'll get 4 minus 5, which is negative 1. If I plug in 3, I'll get 9 minus 5, which is 4, correct? So again, I'm doing 1 squared minus 5, 2 squared minus 5, 3 squared minus 5. Okay, so at 1, we're at negative 4. 1, 2, 3, 1, 2, 3, 4. I'm going to put a solid circle there because, in fact, we are equal to 1 here. At 2, we're at negative 1. And 3, we're at 4. 1, 2, 3, 1, 2, 3, 4. This one makes a curve like this. This is a quadratic. All right, so that is the piecewise function. It has 3 pieces essentially. And we have area 1, area 2, and area 3, which are defined by the domains here as to where they are located for each of the pieces. So it's like doing basic algebra graphs, but you're just doing each one in pieces instead of the entire graph with each one. All right, pause the video, try the student problem for yourself. Okay, so when you do these, there's no particular order to them. You can do them in any order you want. Okay. I just like to go left to right myself because that's the way I read a book. So anything that's less than negative 2 here is the first one. So I'm going to make this invisible line here that doesn't actually exist. You don't need to make the dotted line. I'm just doing it for visual purposes. So y equals negative x squared plus 2. So I'm going to make a table of values. A little extra dash in there. Okay, so x and y is my table. So my table needs to be negative 2, negative 3, negative 4, negative 5. That's probably good enough, to be honest. Maybe that's too many. Because again, my domain here is less than negative 2. So if I plug that in, I get negative 2 squared plus 2. So that's going to give me 4 plus 2. So I'm going to get a negative 2. Okay, so I'm going to plug in negative 3 now. So that's going to give me 9 plus 2, so that's negative 7. I think we're going to go off the graph here, so I'm just going to do one more. I don't think I even need to do that, to be honest. No, I don't think so, because that's going to be 16 plus 2, so negative 14. I don't think I need to do any more. Okay, so at negative 2, I'm at negative 2. That's a closed circle, according to my domain. At negative 3, I'm at negative 7. 1, 2, 3, 4, 5, 6, 7. Next one's off the graph, so we're just going to do that right there, and that is good enough. So the next one's between negative 2 and 3. 1, 2, 3. Okay. So y equals 2x minus 1. We'll do a table of values. That goes from negative 2, negative 1, 0, 1, 2, and 3, because that is my specified domain. So it's a line. This goes between these. So 2 times negative 2 minus 1, so that's what, negative 5? 2 times negative 1 minus 1, so that's what, negative 3? 2 times 0 minus 1 is negative 1. So essentially I'm going up by 2 every time, right? So 2 times 1 minus 1 is 1. Then I get 3. Then I get 5, right? So at negative 2, I'm at negative 5. So 1, 2, 3, 4, 5. I'm going to put an open circle because this domain does not include the negative 2. Okay, so at negative 1, I'm at negative 3. Then I'm at negative 1. Then I'm at 1. Then I'm at 3. And then 3, I'm at 1, 2, 3, 4, 5. And that one is in closed circle because I do include 3 in this one. So connect that line. That's a line. So the last one's a constant. The last one is this one right here, which is y equals negative 3, right? Y equals negative 3. So I'm going to do an x and y table. So this is all values greater than 3. So 3, 4, 5, 6, dot, dot, dot. And these are all negative 3, no matter what you do, right? Because it's a constant function. So at 3, I'm at negative 3. But that's an open circle. And then all of these are just -3 all the way across. Oh, although I completely missed it. And again, don't include the first value because, again, if you look at the domain, I don't include that one. Okay. All right, that is the end of part 4.